All right, this is a continuation from the previous video, which was a factoring review. So we went through each of this section just to the part where it's factored. And so I want to show you why that's necessary and what we use factors for. So the great thing about factors is they'll help us find the roots or x-intercepts of an equation. And if you think about on a graph, any x-intercept you can find is on the x-axis. Now think for a second, what does y equal everywhere on the x-axis? It equals 0. So algebraically, what that means is I can literally put 0 for x. Oh, sorry, I just made that up. Put 0 for y, and then solve for my x's. Now, if you're multiplying two things, you have two factors that multiply to 0. The only way that can be true is if one or both of them individually equal 0. So we just break them up, set them equal to 0, and solve from there. So in this first one, I would divide both sides by 5, which gives me x is 0. On the second one, I would subtract 1, which gives me 3x equals -1, and then divide by 3 and get -1/3. So that's why we want to factor, okay? In the difference of squares example, set your factors equal to 0 and solve. You get 4 and -4. And this brings me to this point. You can only do insider's lie for linear factors where the a value is 1, right? So even though I set them equal to 0, that's an insider's lie, right? +4 here, -4 here. For these two factors, it would give me +5 and -5. Sorry, goodness gracious, I'm tired. It gave me +5 and -1. So even if I set it equal to 0, I'd still have this. Now, be careful when you have a factor that doesn't have an a value of 1, right? So for x minus 2, I can do insider's lie. It gives me x equals 2. But here, insider's lie looks kind of like x equals 2 would be my answer again, but it's not. You want to think about the fact that the step I'm skipping here is setting the factor equal to 0. So I'm going to take this factor, set it equal to 0, and then solve. I would add 2 to both sides, so 3x equals 2, and then divide by 3. X equals 2/3. Right, so that's how I would use my factors to find my solutions. All right, so this bottom part of the notes is working the opposite direction. So when factoring, we had factored form, which gave us our roots. Here we have roots, and we're going to go back to factored form. So here we have roots, we're going to go back to factored form. So x is 8, x is -5. So the factor that would have given me 8 as a root would have been x minus 8. And the factor that gives me -5 as a root, which would have been x plus 5. Because I would have solved it, right? X minus 8 equals 0 gives me x equals 8. And then this is the factored form of the equation. And then it asked me to write it in standard form, which just means to multiply this out. So I'm going to distribute the x, get x squared plus 5x, distribute the -8, get -8x minus 40, and combine my like terms, and voila. For number 6, a root of 0, you can write just x, or you can write x minus 0. And a root of -6 came from a factor of x plus 6. And then writing that, so that's my factored form. Writing it in standard form would mean just distributing the x and getting x squared plus 6x.